Okay, thank you. Okay, thank you. Yes, we'll stay in Belgium. We'll move slightly south, but to an entirely different system. We'll move to the river Scheldt. This is some work did in my former project, so I have my former colleagues listed here. They actually are the drivers behind this. Probably no need to introduce the species. This is Himalayan balsam, Impatiens glandulifera. Maybe except for the fact that it is actually an annual species, which is quite peculiar. By now, or for now, it's actually the tallest annual species within Europe. And of course, this has important implications for managing the species. Himalayan balsam in Belgium. It's established for nearly a century now, but there has been this striking lag phase in its spread because it took several decades for it to actually become widespread all over parts in Belgium. Then as a second part of the introduction on the river Scheldt. The Scheldt in its length is quite a modest river, but it's as close to the Danube as you will get in Belgium. Morphologically, it's a typical rain-fed lowland river with quite of a curly course. But it is a very important river because, of course, it's within this very densely populated region with about 10 million inhabitants in its catchment, with the city of Antwerp, the second largest harbor of Europe by tonnage. So it's an important river to the lowlands, at least society-wise. Now, one very distinctive feature of the Scheldt River is that its mouth is actually funnel-shaped, so like a funnel. And this actually makes the tide reach quite far inland, about 160 kilometers all the way up to the city of Ghent, where the tide then becomes impaired by sluices. So we have a tidal river for this entire stretch. There's also, of course, a salinity gradient from salt to freshwater, but we will stick for this presentation to the freshwater course, simply because Impatiens glandulifera doesn't occur on the brackish parts of the river. Okay, we are quite lucky to have very extensive data, vegetation data on the river Scheldt. There's a huge data set with a vegetation service, and I'll here focus on a set of 85 permanent plots that are installed on the banks of the river Scheldt. So in the freshwater tidal zone, and also a bit in its tributaries, which also have the tidal regime. Now, these permanent plots, the time series I will focus on extend from 95 all the way to 2013, and were taken about 2 to 3 yearly. And this data set allows us to actually very closely monitor the invasion of Himalayan balsam along the Scheldt tidal course. But more importantly, I want to use this data set to understand the niche of the species way better and how this could inform the current management. So I'll jump to some early results already. Here you see the rise of the species in the time period. In 95 already, it occurred on about 60% of the plots, and over the years this has increased to about 90% of the plots. So it occurs basically everywhere. And accordingly, also the cover of the species within the plots has increased from about 10% to nearly 25% with this peculiar fluctuation here. Remember that it's an annual species. For the other species in the plots, well, I should say that these are quite species-poor communities with a highly uneven relative abundance of the species. So basically, these are the 3 other species that make up the cover of the plots. So these are very nutrient-rich and dynamic habitats. And there's no clear trends really in these species. They kind of dominate with one another. This is also reflected in, well, this kind of ecological indicator, the Shannon Diversity Index, which also is overall quite low but stable. But nonetheless, the mean species number in these plots actually have dropped a little over the course of this study. Well, better the monitoring period. Whether this has to do with Himalayan balsam, this we can't be sure. As seen yesterday, the impact of Himalayan balsam on other plants is not really that clear, actually. Now, what we are really after is understanding the microhabitat, the exact niche of Himalayan balsam in this system. And we've used this method called fuzzy set ordination. Now, it's not well known and not used a lot, but actually it's quite an elegant way of testing the importance of variables from vegetation survey datasets. Just as a little example of how it works, you actually have the actual state of the variable of interest, and then the mathematical framework of fuzzy set logic. I won't go into detail, but it uses the similarity purely on the floristic composition of the plots to have an indicator of the apparent state of your variable. And then if you have a correlation, it means that this variable that you are testing for are actually having some effect. So for instance, in this example, you see that elevation does explain a lot of the vegetational dissimilarities, but it doesn't explain all. Here, for instance, the orientation of the slope adds some explanation. Now we used this method on our set of 85 permanent plots. We tested for several variables, but by far the best predictor actually was the inundation frequency, so the frequency with which the plots become inundated because of the tidal mechanisms in the Scheldt. Now we want to study Himalayan balsam in this respect. So now we focus to the plots where Himalayan balsam occurs. And then we see quite of a striking pattern, because the plots with Himalayan balsam tend to center here in the upper left part of the cloud. Now, it means actually that the plots, they actually become inundated quite frequently, yet their vegetation seems to be more indicative for drier conditions. So they inundate frequently, but some mechanism or another makes the vegetation be more of the dry series. Now, if you think of this, and we have some suggestions, that actually this is because if it inundates, the water seeps away quite rapidly. So we are missing something here, something that is very difficult to grasp, namely the drainage or the seepage of water following inundation. And this might actually explain a bit also why Impatiens has become more dominant over the years, because there's several processes in the Scheldt, anthropogenic processes, that have increased the drainage following these inundations. So the high tides, the amplitude has increased, but the habitats has become squeezed as well. So there might be an explanation, or at least a bit of the explanation of why Himalayan balsam has become more dominant. Now, what does this mean for management? Well, the Scheldt is quite prone to large-scale floods, which obviously is a problem, and this is why we are currently having this huge project called the Sigma Plan to increase the flood defense along its course. And the main element of this plan is to create or recreate large-scale floodplains. So this is a schematic diagram of one of the the largest areas where this is being done for now. So at high tides or storm surges, these plains are allowed to flood, obviously. Now, this is a series of sites, but there's two types of sites. There's the regular inundation areas. So during storm surge, we have the river here. The water is allowed to overtop this inner dam, and then you have your inundation area here. But the outer dam, of course, is never allowed to be flooded. These are regular controlled inundation areas. But as we try to make the most of it in an ecological sense, some of these plots are, or some of these areas are designed to be controlled inundation areas with a controlled reduced tide. By having openings in the inner dam, water is allowed into the inundation area for every tidal cycle. So you kind of get a buffered tidal area between the inner and the outer dam. And those are, of course, very interesting for wetland habitats. This is an example. This was the first site to be installed in such a way, having the reduced tide. So we have the Scheldt here. This is the inner dam, and this is the outer dam, which is never allowed to be overtopped. But the water comes here in and out every tidal cycle. And this is quite a small scale area, but we have currently being an area at least 10 times this size being installed. Now you understand that in this controlled reduced tidal areas, the drainage conditions are less extreme. So the tide becomes buffered, and this makes it, or should make it, according to our results, a less favorable habitat for Himalayan balsam, being able to break dominance. And actually, this is what we see from early observations. In very similar conditions outside of these areas, Himalayan balsam is able to dominate, but within it's much less the case. So at least for this system, at least for the restoration of these tidal floodplains along the Scheldt, the future looks quite bright. In the sense that other species or these tidal habitats might be in a more integer or might survive in a better way. And I guess my take-home message to you would be that if you have a system where you can manage the hydrology, then do it cleverly, because you will never get rid of the species, but you might at least be able to break its dominance. That's basically it.
Thank you very much, Bram. Questions? I think this floodplain restoration is very, very exciting, and we are thinking in Hungary the same for a long time, but the political decision makers are not there yet.
Yes, obviously flood defense can be quite a tricky thing, but these are pilot projects for us as well, so it's a bit exciting to see how things will develop, but it seems to be positive story so far.
Yes, I would like to ask you about the ownership of the new flooding plains. Were they private lands or were they public lands?
Mm-hmm. A lot of them were private lands, so the private lands were bought by the government, and this is the reason why actually this Sigma plan has been going on for decades so far. So the initial plans actually were raised in 1976. Yeah, and it took a lot of political discussion and protests and so on until we got to this very first stage. And I'm actually very proud to say that we now have proof that we have actually been able to avoid a large-scale flooding because of these inundation areas. And it's always a bit of a tricky thing, because if things flood, you will get in the news. And then you have a lot of trouble trying to solve it. And if it works, it doesn't flood, but you won't get into the news. That's.
I'd like to ask if you know what is the quality of the water in this river, because in our park, wetlands were natural polders for Vistula River, but it was before 40 of last century, and then we built dams, yes, and then now we wondered if we want this water, because we have a problem with water in Vistula River. Sometimes it's overflood many areas, and we wondered if we want this water to our nature, because the quality of it is not good.
The quality of the water quality from the river, you mean? Whether you want it to go on your lands? Well, yeah. The thing is, yeah. Don't get this wrong. The water quality of the Scheldt is overall quite poor. It has been very poor, but a lot of efforts have been done to improve the quality of the water, and this seemed to be successful, especially since 2007, when the wastewater of Brussels got water treatments, and eventually they end up in the Scheldt as well. Now, so water quality clearly is an issue for this to be ecologically restored. Now, on the other hand, you should imagine that beforehand this was agricultural land. Yeah? So it has largely been dug out. So even given the poor water quality, this is an improvement from the ecological sense. Of course, if you have very sensitive hay meadows here, then I can understand that it's not so clever to do so.
Thank you very much.